Hi guys, for this video, I will going to discuss the series connection of equal resistors. If a number of equal resistors are connected in series to a voltage source E or V in volts, each of the resistor will have a resistance in R ohms. In this topic guys, we're going to use Ohm's law, which I already discussed in my other videos. If a number of equal resistors are connected in series, there are following conditions that prevail. For the number 1 condition, the current I through all resistors is the same. As you can see guys, the total current is equal to the current flowing in resistor 1, in resistor 2, resistor 3, and resistor 4. Okay, the number 2 condition, the total equivalent resistance of the circuit R total is equal to N times R, where N is the number of resistors connected in series, and R is the value of each resistor in ohms. Or simply guys, R total is equal to 4 times R, since the number of equal resistors is equal to 4. Okay, for the number 3 condition, the voltage drop across the individual resistor are equal. Meaning guys that the voltage across the resistor 1 is equal to the voltage across resistor 2, and also equal to resistor 3, and also equal to resistor 4. We go now to the number 4 condition. The voltage drop across each resistor can be solved by E sub R is equal to E sub T divided by N, or simply I times R. Meaning, you just have to divide E total by the number of resistors, or you just have to multiply the current, which is the same across the circuit, to R in ohms. We go now for the number 5 condition. The power taken by each resistor can be denoted as phi sub R is equal to E times I divided by N, or E sub R multiplied by the current I. You just have to multiply the voltage total E sub T by the current I through the circuit and divide it by the number of resistor in series, or simply multiply the voltage in each resistor by the current. So guys, we go now to the examples. For number 1, 4 equal resistors are connected in series to a 120 volt source. The value of R is equal to 40 ohms. Find the current I, the R total, the voltage across each resistor, and the power taken by each resistor. First, you have to compute for each R total or total resistance. So the solution guys, R total is equal to N multiplied by the R, where N is equal to 4 and R is equal to 40 ohms. So R total is equal to 4 times 40 ohms. So the answer guys, R total is equal to 160 ohms. And I can be solved by E sub T divided by R total, where E is equal to 120 volts and R total is equal to 160 ohms. So we have I is equal to 120 volts divided by 160 ohms, and the answer is I is equal to 0.75 amperes. So next guys is the voltage across each resistor. E sub R is equal to voltage total divided by the number of equal resistors connected in series, or simply I times R. So the solution guys will be E sub R is equal to 120 divided by 4. So the answer is E sub R is equal to 30 volts. Or you can also solve using the other formula. E sub R is equal to I times R, which is equal to 0.75 amperes multiplied by 40 ohms. So the answer is also equal to 30 volts. The last one will be the power taken by each resistor, which can be solved by E times I divided by N, or E sub R multiplied by I. So the solution is phi sub R is equal to E times I divided by N, which is equal to 120 multiplied by 0.75 amperes divided by 4, which will result into 22.5 watts. We can also solve that using the other formula. P sub R is equal to E sub R times I, where E sub R is equal to 30 volts and I is equal to 0.75 amperes. So the answer is also equal to 22.5 watts. For my next video guys, I will going to discuss the unequal resistor in series connections. Okay guys, as a summary, this is the list of all conditions of series connected resistor. Okay, number 1, the current I through all resistors is the same. For number 2, the total equivalent resistance of the circuit R sub T is equal to N times R, where N is the number of resistors connected in series and the R is the value of each resistor in ohms. For number 3, the voltage drop across the individual resistor are equal. For number 4, the voltage drop across each resistor can be solved by E sub R is equal to E sub T divided by N, or simply I times R. And lastly, number 5, the power taken by each resistor is equal to P sub R, which is equal to E times I divided by N, or simply E sub R multiplied by I.
Okay guys, thank you for watching. See you on my next vlog. Please don't forget to like, share, and subscribe for more videos.